Welcome back. As you know, I am Eli, the computer guy, here for Silicon Dojo. Silicon Dojo is authorityless, gatekeeperless, free-to-the-end user, hands-on technology education that empowers you to do whatever the hell it is you want to do here in Asheville, North Carolina. So the seminar that I'm about to do for you today, I actually did in person a couple of days ago. Basically, I figure since I already did the keynote presentation anyway, I might as well take an hour to basically record this particular presentation so that you can watch this on YouTube or whatever other video player that you're watching it on. So today we're going to be doing about an hour-long introduction to Python programming seminar. It is important to understand that this is a seminar, not a full class. In today's seminar, this is going to be an overview of what Python is. Why do we use Python? What kinds of problems does Python solve? Why is it an amazing programming language? Some interesting things when it comes to syntax, just for you to keep in mind, and the basic overview about what Python is. We will, to be clear, be having a full 8-hour Python class coming up some point in the future, but that is not what we're going to be doing today. Now, one of the questions that comes up when people start learning a programming language is they start asking, well, why should I learn this particular programming language, right? If you go to a local coder meetup, you're probably going to have a lot of people look at you and say, if you don't learn Node.js, you're not learning a real programming language. Or if you're not learning Rust, then you're just wasting your time. And especially if you're new to the world of technology and the world of programming, it can get very confusing because there are a crap ton of programming languages out there that are very valuable. There's C#, again, there's the JavaScript languages, there's COBOL, there's PHP, there's Ruby on Rails, there's Rust, there's Dart, there's Go. There's a lot of different languages out there. The important thing for you to be thinking about is what problems are you trying to solve? Programming languages are much like normal programs where they all try to solve certain types of problems, right? You could, theoretically, technically, write a term paper using QuickBooks, right? QuickBooks has the ability for you to put in text. It even has, like spell checker and that kind of thing. But you would not try to write a term paper in an invoice on QuickBooks. That just doesn't make any sense, right? You would use, Word or something like that. The same thing is true. If you're going to be creating invoices, it probably makes a hell of a lot more sense to do that in something like QuickBooks. Same thing is true with programming languages. Different programming languages are different for solving different types of problems. So C#, to be clear, a lot of people don't talk about C#. C# is an amazing programming language if you're going to be dealing with the Microsoft stack, right? So if you have legacy Microsoft infrastructure, you have Active Directory, you have Exchange servers, you have all the Microsoft stuff going on, C# is what is going to allow you to really get all the value out of that Microsoft infrastructure, right? Well, the thing is, for us here at Silicon Dojo, basically the paradigm that we are trying to teach is something called IoT or possibly IoE, the Internet of Things or the Internet of Everything. The idea here is that we are going to be programming for multiple different types of electronic devices, computers, a whole bunch of different situations, and the fact of the matter is Python does a very good job with solving our particular problems, right? So basically, we are going to be standardizing on Python here for Silicon Dojo because Python allows us to code for our little robot vehicles, Raspberry Pi vehicles. It allows us to code for Pico microcontrollers. It allows us to create web applications. It allows us to create desktop applications. It allows us to interact with something called serverless architecture. It allows us to interact with APIs and just a whole bunch of things like that. And so why Python can be a very valuable thing is think about it as a programming version of glue, right? If you just need to super glue a whole bunch of stuff together and have it be pretty stable, Python is a good way to go. So to give you some examples of what Python is able to do for you, Python is able to create the little robotic cars that we're going to be using here at Silicon Dojo, right? So this is what is called a Raspberry Pi 4. This is actually a full compute stack. It's a quad-core processor, has 4 gigs of RAM, Bluetooth stack, Wi-Fi stack, the whole 9 yards. And what's really cool with this is basically you can put Python on here, and with Python, you're able to control the wheels. You're actually able to turn this camera camera into a web server, and I've actually done a project where I installed a computer vision onto this vehicle, not talking with anything else, and it is actually able to move and track an object, right? That's one of the things that you can do with Python. This, I don't know if you can really see this on video, this is something called a Pico microcontroller. So microcontrollers are not the same thing as Raspberry Pis. Basically what this is what's called an IC chip. You write code and then it continuously loops through. It looks for inputs coming from sensors and that type of thing. Depending on what you coded it to do, it then sends outputs to things like relays, servo motors, that type of stuff, right? You actually use something called MicroPython in order to be able to code this little guy. Beyond that, again, I've talked about things like computer vision. So let me pull this up. All right, so we're going to pull up OpenCV here. I'm going to hit enter, and this is computer vision. See? So you see how my face, right? You see the video image there, and then you see a circle around my face. And now you see blue dots around one of my eyes. This is actually all being driven by Python. If I go over here and I exit out of that, this is the code, right? So this is the code that's being used, and as you can see, it's about 49 lines of code to actually have a piece of code that's able to read from a webcam and is able to detect both a face and eyeballs. Beyond that, again, when I talked about the desktop app, this is called, you can use something called tKinter is a framework. This is a very crappy, stupid little app. I'm just showing you what's possible. I didn't want to spend a lot of time on this, but we have a little counter app here. As you can see, I can move this around. This is a little GUI interface. If I click on Click Me, we can now see I get a little counter, which again, yeah, I know, it's a stupid example. It's just an example trying to show you what you can do. And then beyond that, this is actually a full web application that I've been building. It's this note-taking app. I'm trying to create a platform for people who like to talk to themselves. Anyways, that's its own story. But this, as you can see, this is 10.0.1.10. This is within Firefox. So this is actually a web application. And I can go through and I can click on things just to show you that it works. We're not going to go into how this actually works today. But this is a full-fledged web application that is being driven by Django, which is a framework for Python. And so this is why Python is so cool, and this is why we are standardizing here on Python at Silicon Dojo, right? We can build robots, we can build web applications, we can build desktop applications, we can build machine vision, you can do machine learning. There is so much that you can do with Python, and you use one syntax, right? One of the big things whenever you're dealing with programming languages is when we talk about syntax. Syntax is basically the language, how you type things out. Things called delimiters. Essentially, when does a command end? If you're in the PHP world or in the SQL world, you would use a semicolon as a delimiter. In the Python world, you actually use white spaces as delimiters. And so one of the issues you can have when you're using multiple different programming languages is, frankly, it gets confusing to keep all of this stuff in your head, especially as you're trying to learn how to do something. And so for us, if we can just simply standardize on one programming language, then everybody knows how to do a loop. Everybody knows how to do an if-else statement. Everybody understands how modules work, that type of thing. And so that's why Python is so cool, and that's why we're standardizing on it here at Silicon Dojo. So now we have to talk about the cons of Python, right? Python can't be that amazing. There has to be some problems with it. And to be clear, if you go to a meetup with programmers, you will be told all the problems with Python. Again, for any new folks out there, just realize everybody has their favorite programming language, and if you disagree with them, they will think you're the Antichrist. Just realize that's how it is. It's kind of like with text editors. I don't know what it is in the Linux world with text editors. People really like very specific text editors, whether it's Vim or Emacs or whatever else. And if you use a different text editor, if you're like me and you use Nano, they will just be very, very, very mean to you. So just kind of keep that in mind. If you have somebody that comes to you and says Node.js is the best programming language, just nod and smile. And then walk away very slowly. But anyways, are there cons with Python? Yes, there are cons with Python. One of the things that's going to come up is that Python is slow. So here, right now, one of the really cool programming languages all the cool kids are using is something called Rust, which is really fast. So if you're using Python, you'll be told Python is slow. So Python is something called an interpreted programming language. We'll talk about that in a second. And so there are multiple layers or levels or whatever systems that the computer has to use in order to be able to make the code function. And so that, yes, that technically does make Python quote unquote slow. Here's the issue. Modern hardware resources are so inexpensive, it's not going to matter for most people, right? I think about this. One of our viewers is actually up in the Yukon territory. He owns a managed service provider company. And for years and years and years, he's been using these things called nukes, next unit compute modules from Intel, right? They cost about $300 or $400. They're small. They're not a hell of a lot bigger than a Raspberry Pi, but they have an x86 processor. You get all the RAM, NVMe drives, and the whole 9 yards. The interesting thing is, years ago, he started using those as Active Directory servers. And I was surprised. Don't get me wrong, I like nukes, but they're so quote unquote low power. And I was like, really? You use nukes as Active Directory servers for your clients? I'm surprised. And he looked at me. He was like, Eli, my biggest client is like 50 users. You don't need that many resources for 50 users, right? And so this is something for you to be thinking about when you're going to be deciding on a programming language, or frankly, any technology, is what is the load on your infrastructure? Again, with us building little robots and some web apps and that type of thing, we're not going to have a lot of load. So I want to use Python because it's so easy to learn. We have one standardization. We can do a lot of fancy stuff. And so the thing is, right, if you're going to create a web application and you're getting thousands of users a day or even tens of thousands of users a day, as far as a modern web server is concerned, it don't care. That's nothing, right? Now, don't get me wrong, right? You start having a web server, you start having an infrastructure that's getting millions of users a day in traffic. Python may end up being slow in that particular situation. Again, with us building robots using Python, right? So we're using standard Linux. We're using Python, building these little robots. And again, we're racing vehicles and we're doing demolition derbies and that type of thing. So this is fine. If you were going to be building robots, for real industrial environments, you probably would go with Robot OS and something else. The important thing to be thinking about is what is your particular situation. Again, when we talk about things like being slow, as far as I understand, I've heard this, but I haven't fully been able to nail it down. I do believe Instagram was originally built off of Django. So, if you're planning for your app to be bigger than Instagram, maybe Python is too slow. Django is that web framework for Python. One of the big things is it doesn't seem to build mobile applications very well. So again, in the world of Python versus the JavaScript programming languages, you'll hear about React Native or you'll hear about Flutter. These are JavaScript frameworks for creating mobile applications or code once, deploy multiple place type languages. And frankly, those do seem to be doing better, right? If I was going to be coming up with a mobile app company, I would probably focus on JavaScript. Python does create mobile apps, adequately, depends on who you are. Probably not going to create the next Angry Bird or something like that. But if you're going to be creating tools for administrative tasks or that type of thing, Python can be useful for creating those mobile applications. But again, probably wouldn't go for it if that was going to be my main focus. The other thing is Python may not work on hosted solutions. So if you go to GoDaddy, if you go to HostGate or something like that, you want to buy a $5 a month solution, PHP is a programming language that allows you to build web applications, and that is basically deployed absolutely everywhere. The fact of the matter is, if you decide to create a web application with Django, which is a web framework, or Flask, which is a web framework, or Fast API, which is another web framework, the reality is you may not be able to simply throw that onto a $5 a month shared hosting plan server. So this, again, is one of those things just to keep in mind. So again, in the technology world, everything has good points, and frankly, everything has bad points. You have to look at your particular situation to decide whether the product works for you. And again, for us, especially with an educational environment, you really can't beat Python for just the amount of things that it can do very well. So you hear me talk about Python, and I say that it's an interpreted programming language. What I mean by it being an interpreted programming language is that you actually write everything out in plain text, and you save those plain text files, and then there's an interpreter on your computer or server that reads those plain text files and essentially turns them into a program. So you hear of compiled programming languages, C or C++. That is where you take the text file, you put it through a compiler, and then you get an executable on the other side. That's not what we're dealing with Python. Python, you're going to type everything out essentially in plain text, and you can literally type it out in Notepad. I mean, God help you if you do it. That's why we have VS Code, but you could type it out in Notepad if you wanted to. All you have to do is end it with a .py extension, and basically the Python interpreter that's installed on your computer, whenever that script is triggered, the interpreter will read the text file, and then it will simply process that file to do whatever it is that you want to do. Basically, Python at this point is installed on almost every operating system. If you're dealing with Windows, if you're dealing with Linux, most Linux at least, if you're dealing with Mac operating OS, Python is actually pre-installed. So that is one of the valuable things with using Python, is you can code in Python, and it should basically work on any operating system that you're going to put it on. I will warn you, though, that the interpreter is installed on all operating systems, more or less, but different frameworks may not be, right? So when I showed you that graphical user interface, that little crappy app using something called tKinter. So tKinter is a desktop framework. It's a framework, basically it's a package of different files and functions that you're able to use in order to complete a certain task, right? So basically being able to create that desktop application. Curiously enough, and this is kind of weird, tKinter is now built into the Windows operating system, as you get it off the shelf. It's built into the Mac operating system if you get it off the shelf. And if you use Ubuntu, like we do here at Silicon Dojo, you have to install tKinter, right? Just one of those quirky things. Like, wait a minute, what? Ubuntu, you have to install tKinter, and not on Windows and not on Mac? So this is one of the issues that you may run into, is that Python will work on whatever operating system you're interacting with, but any framework that you're using, again, whether it's tKinter, whether it's Django, any of the other frameworks, you may have to install frameworks, or you may have to install additional modules to get your code to be able to function. So this is just something to consider. So Python versions, this is something that might get you into trouble. Now, the original Python version, version 1, was created in 1996, and this is the last time that we ever have to talk about it. I have never seen, heard, cared about version 1 in the real world. But we do get to version 2, right? Version 2 is when Python really started to take off. In 2008, the end of life for version 2 was set at 2015, right? So since Python is an interpreted programming language, the interpreter itself is actually a program, and that program has to get updated, it has to get maintained, security functionality has to be added, the whole 9 yards. And so they decided in 2008 that 2015 would be the end of life of version 2. And you know how this goes with legacy applications. Or if you don't know how it goes, you'll learn how it goes with legacy applications. There's the point you want to kill something, and then there's the point you actually do kill something. Version 2 was actually extended all the way till 2020 because sadly people kept using version 2, they kept adding to the code base, and they didn't move to version 3. Now, why is this a problem, right? If you're dealing with PHP, if you're dealing with many programming languages, right, you have version 4, you have version 5, you have version 8, but if you deal with PHP, version 4 code should work on a version 8 interpreter. right? Certain functions are supposed to be deprecated, but normally they continue to work, so you normally don't have a lot of problems. The issue with Python, this is something to keep in mind, is that version 2 and version 3 are very, 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 very different, and more or less the code that you write for version 2 will not work on the version 3 interpreter, and vice versa. So now, again, we're fully in the 2020s at this point, so you should only be dealing with version 3. Why this might become an issue for you is if you go to Amazon right after this video, you're like, wow, I really want to learn Python. I'm going to go old school and buy a book on Python so that I can understand it better. Something to pay attention to is make sure you don't buy a book for version 2. I actually ran into this problem with the Raspberry Pis back when I started learning how to deal with the Raspberry Pis. I saw a dummies book on Amazon because I like the dummies book. And it was for, how to use Python with Raspberry Pis. I got it, and it was for version 2 of Python, which basically means it sat on the shelf collecting dust because version 2 is crap. So if you're going to go out there and you're going to buy books, you're going to go to like a bargain basement, you're going to go to the library and get any information about Python, make sure you're getting version 3 information. So let's go a little bit more in depth with some examples of how Python is actually used for all these different projects that we're going to be doing, right? So basically this is a Raspberry Pi here. So this is a Raspberry Pi board. And in order to be able to interact with what are called the GPIO pins. So if you look at a Raspberry Pi, there's these little pins up here. They're called the GPIO pins, that connect to the motors and the sensors and all that kind of stuff. Oops, it's falling apart. Anyways, when you're dealing with the GPIO pins, you need a library called GPIO 0. So when you're using the Raspberry Pi OS, GPIO 0 is already built into the Raspberry Pi OS. And so basically what you're able to do is you're able to import the module. We'll talk about modules a little bit later. You're able to say what pin a device is connected to, right? So for this particular project, what we want to do is we want to make an LED blink. So we're going to connect the positive line of this LED to pin 17 of the GPIO pins. We're going to connect the ground to a ground pin on the Raspberry Pi, and then simply we're going to create a while true. So this is just a continuous loop that never stops. Red on, so we're going to turn the LED on. We're going to sleep for 1 second. We're going to turn red off. We're going to sleep for 1 second, and then we're going to loop, 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 loop. And so this is a very, very, very basic example of what a Raspberry Pi Python program would look like. Now this here is a diagram of the Pi. This is actually a Model 3. Ignore that, ignore that. It's actually a Model 3 Raspberry Pi pinout. Again, these are the GPIO pins on top. And then what you can see here is that all these GPIO pins are identified, right? So pin number 1 is a 3-volt power connection. You might use that for different types of sensors and things. Pins 2 and 4 are 5-volt power connections. Pin 6 is a ground connection. Then you have GPIO 4, GPIO 14, a ground, GPIO 15, the whole 9 yards. So basically when you're sitting there and you're typing out your Python code, what you're going to do is you're going to identify the pin that you want to turn on or off or read information from, and you're going to use these GPIO pin numbers to determine what you actually plug into your code. Again, if you're going to be powering sensors, if you're going to be powering motors, that types of things, you would then connect to the power or to the ground pins on the GPIO pin outputs. Then we get to the Pico. So again, the Pico is a microcontroller. This is not a full compute stack. Again, this is much more like an Arduino, right? When you look at the Raspberry Pi, that is much more like a full-fledged computer. You can actually have a full-fledged desktop computer with a Raspberry Pi. You could have a full-fledged server with a Raspberry Pi, and you can do things like build robots and all that kind of stuff. That's not the same with the Pico. A Pico is a microcontroller. Basically, all it does is it reads from sensors, it continuously loops through, depending on the value of sensors or whatever inputs, it then triggers certain events to happen, and it just keeps rolling along. So with a Pi Pico, we use something called MicroPython. So MicroPython uses essentially the exact same syntax as normal Python. It's just a much smaller version because it has to fit on this instead of a full-fledged computer, right? And so we can look over here, we look at the code from machine import pin and timer. That looks a lot like what we just saw. We create the LED pin here. That's slightly different. We create the timer. The function, basically blink, looks about the same for how you create a function. And then you have this down here where you actually run the particular function. And so if you take a look at this, this is a little bit different. MicroPython is a little bit different than standard Python, but it's the type of thing that if you're used to coding in Python, it's pretty easy to get used to this type of deal. If we look at this, so basically with the Picos, when you buy them, they don't solder the headers on for you. The headers are actually those pins. So just a warning, you buy these for $4 and then you get to solder the headers on. Oh, I hate soldering. I wonder how much it would cost to send these all off to Louis Rossmann and get them soldered. Anyways, but if you solder the pins on, you can plug this into what's called a breadboard, and then these are the wiring connections, again, for an LED. So with this particular code, what this does is it basically makes an LED blink. So this is the wiring diagram for how you physically connect an LED to this, and then this is the code that will make the LED blink. The Pi Pico has a pinout, kind of sort of the way that the Raspberry Pi 4 does. Basically, you can see all of the different pins here. We can see the ground power here. We can see the 3 volt power over there. Then we have the different ways that we can identify these different pins. And so basically, when you're going to be creating a device with the Pico microcontroller, when you're writing out the code, you would go to this to figure out what pin you should connect to what particular device. You would type that into the code and you would go from there. This is something we will have a full class on. I kind of just want to give you an idea of what's going on here. So past robots and past microcontrollers, the thing that really made Python stick in the technology world is something called APIs, Application Programming Interfaces, right? Again, if you look at my career, I've been doing tech since 1996. PHP was really, really popular in the aughts. I don't know, do we call it the aughts? I don't know, from 2000, let's say 2009, 2010, PHP was one of the big programming languages, and about 2010 is when things really started to switch over to Python. The reason is because previously, what we were dealing with is we were dealing with our own infrastructure, right? So I had my own web server, I had my own database server, I had my own email server, I had my own data stores and all of that type of stuff. And I simply needed to be able to glue them together. And so PHP was a very good language for gluing together the resources that you own. Again, your web server, your email server, your storage servers, glue it together with PHP, right? Well, we get to about 2010. This is when AWS was starting to become the cool new thing. This is when we start getting SendGrid for things like email services, Twilio for SMS services, all kinds of different stuff. Twitter had an API, has an API. I can't even keep up with Twitter's API. I'm not going there. Anyways, Twitter's API used to matter, right? Anyways, with an API, basically what this is somebody else owns the infrastructure, right? So if you want to be able to send an SMS message, instead of connecting to your own server, where there's a way to do that, what you would do is you would connect to their infrastructure in order to be able to send or receive an SMS message. With that, you need what are called API keys. So basically, you need the endpoint information, what you're connecting to, something like an IP address or a domain name. You would need a username or a key or a secret or something like that to do the security to make sure you're the right person. And then basically that way your program, you don't need to own an email server. You don't need to own an SMS server or whatever else. Your program simply goes out, connects to their infrastructure, and then uses those particular resources, right? Again, 2010 APIs really started to come into vogue because frankly, they're great. The thing is with APIs is how you interact with that API is all based on what the vendor allows you to do, right? You do more or less. You do not write your own APIs for some other vendor. The vendor says, this is how you connect to our services. And that's it, right? So if they have a Python API, you use a Python API. If they have a PHP API, you use a PHP API. If you have a JavaScript API, you use that. Well, the thing is, you go back to 2010, and everybody was coming out with Python APIs. So basically, if you were using the Python programming language, you were able to connect to all these wacky, cool, amazing services. And if you were using PHP, you were stuck. You were stuck. You weren't allowed to. One of the reasons that PHP hasn't died over the years is they've actually come out with PHP APIs now. So a lot of the services that exist, they actually now have PHP APIs. But again, you go back 10 years, those APIs didn't exist. So when we talk about APIs, again, this is any kind of resource you're going to be connecting to that essentially somebody else owns. Sending out that SMS message, sending out emails, being able to store stuff. Imagine being able to do online backups, that type of thing, possibly connecting to some kind of database services. Again, Twitter, they had an API, or they do have an API. I don't know. There was a time you could send tweets through the API and receive tweets through the API, but the idea is you can just have your Python code and be able to essentially outsource those services using APIs. And then we get to serverless architecture. Oh! I love serverless architecture, I really do. Anyway, serverless architecture is amazing. How do you know Eli is still a geek? Because I get really excited about crap nobody else seems to get excited about. Anyways, there's something called serverless architecture that is phenomenal. Again, you will hear me go on and on and on about something called Azure Cognitive Services. These are AI-like services that you're able to connect to basically with an API call. So what do we mean by serverless architecture? Serverless architecture is when the API that you're connecting to actually does processing. Right? So when you're connecting to Twilio for SMS messages, you just simply say, this is the message that I want to send to this person from this person. And it sends it out, right? There's no real processing on that. If you want to use SendGrid and send out an email, this is a message, this is a subject, this is a from, this is a to, and it gets sent out, right? There might be some modifications in there, but that's basically all there is. Serverless architecture gets really awesome because you actually start connecting to CPU compute resources as easily as you can send an SMS message, right? So like with Azure Cognitive Services, like with Vision, right? I really like Azure's Vision services. You can either have a video feed or you can have a still image. You send that video feed or still image up to Azure services, and then it responds with what's called a JSON response, which is basically it's a data in a particular format for the web. So anyways, it basically sends data back using something called JSON that tells you what's in the image, right? So if you have a picture and you're like, what's in this picture? You literally send the picture to Azure Cognitive Services. Azure Cognitive Services looks at the picture and says, there's a dog, there's a hat, there's a ball, there's a pool, and there's ice cream. And it says, what the color is. The predominant color in this picture is purple. All of that kind of stuff, really cool. For speech, you can actually do real-time speech with cognitive services. I actually did this for a seminar about 2 years ago for Silicon Dojo, where I can have a Python script. I turn the Python script on. I start talking to my computer. My computer in real time sends that up to Azure Cognitive Services. Azure Cognitive Services then sends back down plain text. Once I have plain text, I can simply parse that because it's text, and then depending on what's in that plain text, I can have certain things fire off in Python, which is absolutely amazing. And so Python allows you to connect to this kind of serverless architecture, and there is so much out there. If you go to Microsoft's Azure's services right now, I think they have something like 250 different services. And so you can have a pretty simple code, right? You may have a little program that may have 20 or 30 lines of code. But in that 20 or 30 lines of code, if you can connect up to Microsoft servers, you can actually have something insanely powerful because basically your code is handing something off to that serverless architecture. That serverless architecture is burning a lot of resources and going through a lot of stuff in order to give you a response, and then the response you get is plain text that, you know, any couple of lines of code will be able to parse and do something with. So serverless architecture is one of the things with Python that is absolutely phenomenal. Now with Python, one of the frameworks that is available for you, again, is tKinter. For some reason, tKinter is installed on Windows and Mac. Does not appear to be installed in Ubuntu by default for some reason. But this is a GUI framework. So basically with this framework, what you do is you're able to trigger your code runs, and instead of getting a web application or getting a robot or something like that, you actually get a desktop application. So something that you can double click on and get file explorers and all of that kind of stuff. So this can be very useful for you, especially if you're going to be like you're going to be a systems administrator, you're going to be in the tech world. The ability to be able to create dashboards, the ability to be able to create tools that you're simply able to click on things or type information into and not have to deal with stuff at the command line, that can be absolutely awesome. The other thing with Python is you can connect to databases just like you can with almost any other programming language. So if you're going to come up with a CRM solution for your company, again, a special, you know, specific CRM solutions, customer relationship management solution, an invoicing solution, something like that, you could actually use tKinter or another GUI framework. There are other GUI frameworks out there to be able to create a full desktop application that allows users to input information, be able to get reports, and all of that kind of stuff. The cool part about this with Python is you could have one interface that's a desktop interface. You could have a different interface using something like Django that's a web interface, and then you could code all kinds of fancy, you know, machine learning or stuff in the back end. So imagine you wanted to create a checkout system for a company, right? So, you know, somebody comes through the checkout, you ring up all the items. Basically, you could code a desktop application so they could ring up all the items and take the payment. And then with Python, as the items are run through, those items can be then taken out of inventory, right? Since you have an inventory database, you could remove those items from the inventory database, and then you could have another Python script that scans the inventory database, sees how many items have been sold within the latest period of time, and then that could auto-create a report for your manager on how much of what items to purchase going into the future. Or with your vendor, you might actually be able to set something up automatically. So basically, imagine a shopping list for your company where as the items in your inventory go down below a certain level, the items are automatically ordered from your vendor. That's some of the cool stuff that you can do with Python. And again, being able to create these GUI interfaces that'll work on Windows or Mac or any kind of desktop application can be very useful. Then we get to the web frameworks. So when we talk about web frameworks, I like Django, and I cannot lie, right? Anyways, if you come to Silicon Dojo, you're most likely going to be learning Django. Unless I start liking Fast API or Flask, right? Those are other frameworks that are out there. Again, something to be thinking about whenever you're dealing with Python is that there are multiple frameworks out there many times to basically solve the same types of problems. So again, tKinter is one framework for being able to create desktop applications, but there are other frameworks out there. The same is true for creating web applications, right? Apparently, again, as I've been able to read the tea leaves or whatever, it seems that Instagram was originally created with Django. So Django is a framework for Python for creating web applications. Now the nice thing with Django, it has a built-in user account system from the get-go. So as soon as you set up a Django, you already have a user account system. That's very nice. It has a lot of other functionality that I just think is pretty good. And so this allows you to create a web application. Now again, there is something called Fast API that also allows you to create a web application. It has its own, quirks. One of the big things with Fast API is that it's fast, which, might matter to you or it might not. If you have a few thousand users going to your web application today, you might not need Fast API. If you have millions of users going to your web application today, maybe you do need Fast API. and depends upon your use case. So anyways, fast APIs out there. There's also something called Flask. I took a look into Flask. I don't know. I don't like the look of Flask. That's just kind of me. But the important thing to understand is that you can create web applications with Python. Now, one of the big things in the modern world in the 2020s is what about mobile, right? Mobile is, I don't know, honestly, it seems like so 2012, to be honest with you. I don't know. When did creating iOS apps become, 5 minutes ago? Maybe that's just me. But anyways, the big question is, can you create mobile applications with Python? And so there are different mobile frameworks out there. There's a framework called Kivy, Kivy, and there's a framework called Pybee, Pybee, and basically these are frameworks. It's essentially the idea is code once, deploy in multiple places. So with Kivy, this is the weird logo for Kivy, you can create an applications on Kivy and you can deploy it to Linux, you can deploy it to Windows, you can deploy it to Mac OS, you can deploy it to Raspberry Pi OS, obviously, you can deploy it to Android, and you can deploy it to iOS. When you're thinking about using Python and their mobile frameworks, my advice would be, again, know your use case. What's interesting about this is I was doing research about these mobile frameworks about a month and a half ago, and I swear to you, when I read both Kivy's information and Pybee's information, within their official information, they said that they were kind of sort of garbage. And I'm not being mean that way. It was like, well, these are beta products and they have quirks. Curiously enough, again, a month and a half later, I'm going to do this seminar. I want to get a screenshot of their own documentation saying that their product is crap. I can't find that anymore. I don't know. Maybe it was a fever dream, or maybe they deleted it. What I would say is if you're going to be using Python for mobile applications, again with Kivy or Pybee, again, honestly, really think about what you're doing. I think, again, currently right now, when I'm filming this particular seminar, if I was going to be doing mobile app development, I think I'd go React Native or Flutter, honestly, and so that's a JavaScript language. I wouldn't be doing Python. But again, you got to be thinking about your particular situation. So if I was going to be selling my product, right, out to the consumers, I probably wouldn't use Python. On the other hand, again, think about this. What if you needed to create specific tools for troubleshooting your environment or maintaining your environment, or you need to create specific tools for the employees of your company? Doesn't need to be the fanciest, doesn't need to be the flashiest, doesn't have to have all these kind of, accelerometer, sensor information and all that kind of stuff. Basically, you just need your employees going, right? If you need your employees or you to be able to go on a button and get some information, I would use a mobile framework in Python. Again, you got to start going more towards that consumer end. I would probably question that. So if you're going to be using the mobile frameworks, make sure to do your research on it. We will be having full classes on these mobile frameworks. I just frankly have to get fully up to speed in order to do the classes because they are very interesting. Again, if you're going to be doing very basic things, it can be very powerful to simply use Python in order to create those applications. But, be careful. Understand your requirements. Now, when we start talking about coding with Python as a programming language, one of the cool things that Python has is something called virtual environments. Now, basically with Python, Python's real power comes from something called modules. Almost everything that you're going to do in Python is going to require a module, whether it's timing, simply setting a delay to delay a program for a certain amount of time. Again, when you're doing a blinking LED, that needs a module. Connecting to SendGrid needs a module. OpenCV, computer vision needs a module. We're going to talk about modules in a second a little bit more. But basically, any Python program that you're going to create, like almost any, are going to need modules. Now, modules, much like the Python interpreter and any other kind of software, they have versions. They have versions 1, 2, 3, 4, 5, 6. So on and so forth. One of the issues you get into in the real world of creating infrastructure is sometimes the code that you wrote will work for version 1 of the module, but will not work on version 4 of the module for some reason, right? Especially in the open source community, somebody decides they're going to change the naming conventions or something within the module, and all of a sudden your legacy application breaks. The problem you can run if you're dealing with like the PHP world or some other programming environments is that when you update the module for one application, that's the same module that's going to be used across the entire server. So you can run into a problem where, what if this application needs version 1 of a module, and this application over here needs version 4 of a module? What do you do? And again, you go into virtual computers, you use Linux containers or something like that. The cool thing with Python is you can create a virtual environment, VENV, and what you can do is you can install version 1 of a module into this virtual environment, run this script within this virtual environment, and then you install version 4 of a module in a different virtual environment and run a different script in that separate virtual environment. So that way you can use the same server, the same operating system, but then you're creating virtual environments for the scripts to be able to run. And this is actually a very useful thing in the Python world. Now, when we start talking about modules, we're going to be using something called pip to install and to manage our modules. Basically, it's a package installer program. What you do, just like when you're in Linux and you do sudo apt install whatever, Apache or whatever else, same is true with pip. So let's say you need to install the OpenCV module for Python. You would do pip install whatever it is, OpenCV-Python, I think it is. If you need to install the SendGrid module, so you can actually be able to do email services, you do pip install SendGrid, whatever the module name is, right? And so that allows you to install modules onto your Python interpreter so that you're able to access the services. If you need to see what modules are installed within your pip, you can do the command pip list, and it will then show you all the modules that are currently installed. And so this can be a very useful thing if you're coming in behind somebody and you're trying to administer or manage a system that you were not the one to build. You can go in and see what packages have already been installed. And so when you go to code something for that particular server, you may realize that you need to use one module instead of another. But pip is going to be something that you're going to become very familiar with in the Python world. So modules, I've been talking a lot about modules, and so basically modules are add-ons for your Python script to allow your script to do whatever it is you want your script to do. Again, do realize in the Python world, it can be as simple as simply timing your script. If you want to delay the script by a second or a millisecond, you actually need to import the time module. If you want something as simple as a random number, you actually need a module for the random number. Why this is actually useful is it actually makes Python secure after a fashion. So sometimes with hackers may be able to compromise a script, let's say that you wrote in something like PHP, and if they're able to compromise that script, and that script has the ability to do something, they may then be able to do something nefarious that they shouldn't be able to do, right? Again, PHP has a email functionality built into it. It has a lot of stuff that's already built into it. So if a hacker can compromise that some way, they may be able to use your server to email stuff out or do kinds of weird things. One of the interesting things with the Python world is since you need to add every module to do almost anything, that means if somebody is able to compromise your script, many times they're stuck because there's just not any additional functionality for them to be able to do, right? Again, if you have to add a module simply to delay your script from doing something, that's how tight it is. Let's see here. One of the things you can look at is aliases. So whenever you import a module, you can import a module and actually recognize it as a certain alias. And so that's something you can say import module X as Y, and then when you reference that module later, then you would actually reference it as Y. So this is one of the things that you can do. And with that, let's actually go over to the code for a second, kind of so I can show you how these modules work. So if we take a look at this script, this is the script that runs that OpenCV application that I was showing you for, right? That was able to detect a face and was able to detect 1 or 2 eyes depending on the lighting condition, right? So anyways, this is about 49 lines of code that allows you to do face detection. And when we're talking about modules, the module part is what's up here, right? So we can see import CV2. So CV2 is the module for computer vision. And then that alias that I was talking about as CV, right? So then as we go through this particular script, we can see wherever the CV2 module is talked about with CV. So frame gray equals CV.CVT color, CV.equalize hist. If we keep going down, we can see these different places where they call CV instead of CV2. Now, the point of aliases, what I've been told is the point of aliases is that if you have a really obnoxious module name, the concept is that you can make it nice and short. So instead of saying OpenCV Python module and having to type that 50 times in your code, the idea is you could do import OpenCV Python module as CV and then just call it as CV, right? That would make life a lot easier, essentially create that little text shortcut. One of the things you do find when you're going through and you're dealing with Python scripts that other people have created is that many times they use an alias for CV2. That extra number is just too many numbers. It's just too many letters. Why am I going to write CV2 when I can simply write CV? Which, again, functionally works, technically it works. It just can be a little bit confusing, especially when you're reading other people's code. And so basically that's this as CV, all that is an alias. Again, think about it as a shortcut. Then we have this down here, import arg parse, basically for parsing different arguments. We parser equals arg parse dot argument parser, blah, 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 blah. And so that's one of the things that you'll see too, is that these different modules are required to do different things. Like one of the big things with Python is that they actually don't have arrays installed as a default option in Python. You have to use the NumPy module in order to be able to use full-fledged arrays. And so that's going to be like one of the weird things that you're going to run into sometimes is many times you're going to know what you want to do with your code. You're going to know that Python can do that, but you just have to figure out what frickin' module it is that will accomplish what you're trying to do. But anyways, this is kind of like a basic idea of what we're talking about with modules. Now, the next big thing whenever you're dealing with Python is that Python really cares about white space. Python wants your program to be pretty. Oh, so pretty and wise. Well, maybe not wise, but they do want it to be pretty. All right, so one of the big problems you get to with some programming languages, such as PHP, is that they use a delimiter, such as a semicolon, so the command ends and you use a semicolon. And one of the issues you can run into with PHP is you can literally have one line of code that goes forever and ever and ever and ever and ever and ever. And it actually functions properly. Technically, it works properly. But it is horrible because you have to go in and maintain or change something in that code. It is just ugly as hell, right? You can run into a real problem with code and with different languages where they don't use white space as a delimiter, where you can have code that works perfectly, but literally trying to read it will drive you out of your mind. There is a programming technique called minify. You don't see this a lot in the 2020s, but it used to be big about 10 years ago. And what minify is a way to actually remove white space in programming languages such as PHP and JavaScript, because if the interpreter has to deal with white space, it takes just a little teeny bit of time. So again, you go back 12 years ago and all that little bit of time actually made a difference, right? One of the useful tools with minify, though, one of the useful values of minify was it was actually a way to kind of obfuscate your code, because basically if you rip out all the white space in a PHP script or a JavaScript script, it's just all this just block of words. You don't even have to encrypt it to make it darn near unreadable, right? And that was a big problem. So with Python, one of the things with Python is that basically the white space is actually used as the delimiters, so you need to make sure you use the white space properly. So you'll see here, when we're importing these modules, this is all the way to the left, define, so this is a function that we're creating, that's all the way to the left, and then under this, right, we tab in or we go a white space in order to start saying additional information. Frame gray equals, faces equal. And then when we go to a for loop, so basically a for each loop, a for loop, we see that, but then we go in another amount of white space, and then we come down and there's a for loop within this for loop, and then that goes in another amount of white space, and then basically as we get done, right? And so what's really nice about this is it actually makes your code very, 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 very readable. Now, it is important to understand in the Python world, though, if you do not use the white space correctly, your code will fail. Your code will fail. White space is important. So if you don't do this, how you're supposed to do this, you may run into a lot of problems. Now, when you're dealing with Python, there is that whole argument. Do you use spaces or tabs? Did you ever see the Silicon Valley episode where the main guy was trying to get it on with the girl? He had this girl and they were doing really well. And then they started talking about spaces and tabs, and he was like a space guy. She was like a tabs girl, and then everything went to hell. Yeah, that was probably closer to reality than any of us would like to admit. There are spaces people and there are tabs people. Anyways, from a technical standpoint, it doesn't matter. But if you're going to be using spaces, so a single space in can be used, or a tab in can be used. You should not be mixing spaces and tabs, though. This is something we'll go over in a full class. One of the things that can make this very confusing, though, is with NVS Code. Sometimes when I start getting scripts that really start getting pretty big, you can actually shrink how much a tab is. So a tab isn't always a tab. So like right now, you can see this is a tab, and this is a tab, and these are tabs. You can actually modify so when you look at a tab, it actually looks smaller, and it looks like only a space. So again, that might be one of those weird things that you run into, something to keep in mind. Now, one of the big things that you're going to run into if you're used to other programming languages, again, like PHP or a lot of other languages where they have arrays built in, is that Python does not build in arrays. They have lists and they have dictionaries, and they also have other things depending on what you're doing. They don't have arrays, right? So the thing is with lists look a lot like an array. You just don't get all the functionality. So when you actually deal with arrays, arrays allow you to do a lot of mathematical computation, a lot of fancy stuff with all of the items that are in the array. When you're dealing with a list or a dictionary, you don't really get all of those options. When we're talking about a list, essentially this is a numbered array, if you're used to knowing what an array is. So with this, we have test list equals, and then we have bracket. At index 0, we have item 1. At index 1, we have item 2. And at index 2, we have item 3, right? So this is what a list looks like. We can do print test list. We can print this out on the console to show us what the test list looks like. We can do a for x in test list. This will loop through this list and then print out the items that are in this list. We can sort this list, so we can sort them by the values, and we can count the list. We can do things like count items in the list. So there is a lot of functionality in lists, but it is important to understand there might not be as much functionality as you're expecting, and that's why you might need to use a module such as NumPy that will actually give you full array functionality. Now, when we're normally talking about arrays, you will hear of something called an associative array or a named key array. And what that means is that you can actually name the index. Instead of index 0, index 1, index 2, we can name the index name with a value of Bob. We can name the index age with a value of 14, and we can name the index t-shirt for like t-shirt size with a value of large. The important thing to understand here is this is a dictionary and not a list. So when you're dealing with lists and when you're dealing with dictionaries, if you use the wrong command, you will get an error that gets spit out that says you can't do that with a list or you can't do that with a dictionary. Kind of one of those things just to keep in mind. For this, we could do a for loop for x, y, in text dict period items function, we could then print out the value of X, so value of the named key, so name, age, or t-shirt. We can do a little arrow and we can print out the value of Y, Bob, 14, and large. This is kind of what it looks like in order to deal with a dictionary. It is just very important to understand arrays do not exist in Python by default. Lists are for normal, just a list with normal index values. If you want those named keys or an associative array-ish type thing, you're going to be dealing with dictionaries. Now, when we get to data types with Python, again, this is one of those things where Python does things a bit its own way, where the cool part about Python is you do not have to manually set a data type. So in some programming languages, right, when you create the variable, you have to set the data type as an int, a float, basically a decimal point, as a string, as a bool, as any of these different data types out there, right? One of the problems you can run into if you have a programming languages that doesn't allow you to assign data types, so basically plain Jane JavaScript, you can run into issues where you start trying to add Bob plus 15 and you get crap, right? So the cool part about Python is that you have data types, you have assigned data types, but you are not the one to assign the data type. Python does it for you automatically, which we all know how automatically works in the real world. So one of the things you just have to be thinking about whenever you're dealing with variables in the Python world is that Python may have set a data type that you were not necessarily expecting, right? So again, we have the normal data types, bools, strings, floats, ints, all that kind of different thing. One of the things you can do if you want to print out what something is, you can actually use something like str. So str function will turn, let's say, a list into a string or a dictionary into a string. So sometimes there are data types like tuples. We'll talk about this in the future. One of the problems you can run into is sometimes programs output a data type and you're not sure what the hell you're dealing with. So one of the things you can do is you can actually print. You put the variable and then you do string, you put it within the str function, and then it will simply print out the text. And that will show you if it's a dictionary, that'll show you if it's a list, it'll show you if it's a tuple, it'll show you if it's an int, it'll show you everything is. Again, in the PHP world, think about this as kind of like a var dump, just something to keep in mind. Beyond that, you can actually print out the type of something. So if you just simply want to know the type, you don't want to know all the information there. So test list, you could print type, test list, and then this would tell you it's a list, it's a dictionary, it's whatever else. Again, that's one of the problems you get to again with the lists and the dictionaries. Sometimes you think you're going to create a list and then you actually create a dictionary, but you called it a list, and so you still think it's a list, and then you try to do things on it as if it's a list and it's a dictionary, everything goes to hell. Anyways, so you can use type to find out what the actual type is of that particular variable. And then you can also change. You can change the data type by using things like str or int or different types of functions. So you can actually take the variable that you have, the variable value that you have, you can put it through an str. So this would turn a float into a string. Basically, you can put it through this function and then assign that value to a new variable, basically to give you the variable with the data type that you are looking for. So this is, again, we'll talk about data types in the full-fledged class. It's just something to keep in mind because it can get quirky really fast in Python land. Now, running a Python script should be relatively easy. Depending on what operating system you're using and what version of the operating system, you may have both version 2 of Python installed on your operating system and version 3 of Python installed on your operating system. Again, generally at this point in time, we should only be doing version 3. So if you want to run a script, simply type in Python 3 and what the script name is. So go to the directory where the script is located, type in Python 3, the script name, and the script should fire off and you get whatever. You may, and again, in the Linux world, you may have to put sudo in front of that if you need some kind of administrative permissions in order to do something with a particular Python script. But again, Python 3 and the script name. Some operating systems, or depending on how you've configured your operating system, you may be able to simply put Python in. All I'm going to warn you here, though, if you create your fancy little Python 3 script and then you put Python script name and it fails, Before you start ripping through all of your code trying to find the problem, just put a little 3 on the end of that Python, and I'd almost guarantee you that's going to solve the problem for you. Now, the final thing that I'll say when we're dealing with quirks in the Python world is that you can run into weird issues with script naming. When you name your script a value that Python cares about, your script may fail and not really give you any reason for why it failed, right? If you name your script something like what another module is named, so if you name your script time.py, your script is probably going to fail, right? If you name your script numpy.py, because that's one of the things that I do, right? Again, I don't know, not the sharpest tool in the shed sometimes. So I'm like, oh, okay, so I create this script, and this script is where I'm testing numpy. Oh, so what am I going to name this script? Well, why don't I name this script numpy.py? So I remember what this script is about. And then I name it that, and it fails. Because it's the same name as a module, and everything goes to hell if you do that. So one of the things that I'll say with the script naming is whenever you're going to be naming your scripts, try to make sure that it's unique, try to make sure it's your own little creation that you've created and is not going to be the same name as a module or something else, and you should be fine. Again, if you're sitting there, if you created your script, you do not see any errors on the script, it seems like the white space is okay, and your script will not run, just change the name of your script, and many times that'll solve the problem. So there you go. There's the Python seminar for you. We've talked about all of the different uses for Python, how we can use Python for doing everything from creating robots to creating web applications, desktop applications, communicating with serverless architecture, all of these different types of things. I have tried to tell you the cons. Python is not perfect. I've told you that, right? So we've gone over those. We've talked about white spaces. We've talked about modules. We've talked a little bit about pip, kind of shown you the different types of things that you're able to do with Python. And so this is why I think Python is really, really, really exciting. And again, you got to be thinking about your environment. Like right now, for some reason, Rust is the amazing, cool programming language. But here's the thing, when you look at your environment, a big thing that you have to think about is the maintainability of your infrastructure, right? Who is going to maintain your infrastructure when you're not there? Either when you leave, frankly, when you just get sick, right? And so if you have code bases, and some of your code bases in JavaScript, and some of your code bases Ruby on Rails, and some of your code bases in Rust, and some of your code bases in Python, that sucks to maintain, right? Because again, even if you have a professional programmer that's been doing programming for 10 years, the fact is they're going to be used to their own little world, and all of a sudden you're going to dump them into a new programming language. And again, it's just simple, like these simple syntax things. What delimiter do you use? How do you do if-else statements? That kind of crap, right? And the more they have to spend time figuring out that stupid stuff, the worse it's going to be for everybody. So if you can just streamline and use one programming language, one syntax across your infrastructure, that makes everybody's life so much easier. Again, I've shown you Python has been around since 1996. In the 2020s, Python is a modern programming language. It is completely updated. The end of life for Python 3 is way in the future. So really, I do think that this is a useful thing for a lot of people to be thinking about for in their infrastructure and that type of deal. Going into the future, again, we will be having a full Python class. We're going to have a Python class, an 8-hour Python class. We're going to have an 8-hour Django class. We're going to have an 8-hour OpenCV class. We're going to have an 8-hour GUI class. We're going to do all kinds of stuff with Python. So stay tuned for those videos whenever those videos show up. Or more importantly, think about coming here to Silicon Dojo. Again, authorityless, gatekeeperless, free to the end user, hands-on technology education that empowers you to do whatever the hell you want to do. We're here in Asheville. Basically, we have an open RSVP system. Again, our classes are free to the end user. What that means is you sign up and you don't pay anything. You just show up. right? Basically, we get paid through crowdfunding. There's a little donor box link or whatever somewhere around this video. People are nice enough to click on that donor box link, throw some money into the account, and that's what is able to pay for this facility and to make sure that this happens, right? So I will say, I'll do a little e-begging here. If you like this particular video, if you like the idea of Silicon Dojo, crowdfunding link. I'm just saying the crowdfunding link exists. You don't have to give any money, but if you want to, it's down there. But anyways, as always, I enjoy doing this particular video, and I look forward to seeing you at the next one, and more, I look forward to hopefully seeing you here in Asheville, North Carolina.